Okay, so I had a customer bring to me a light bar off of a vehicle, and it's already been disassembled. The lens is off of it. I have it connected to my ancient 30-plus-year-old Astron 20 amp power supply. I'm going to switch it on. And so right off the bat, you can see what's going on. I have some LEDs that are not lighting over here. So if I show you the rest of the unit, those are all good. And then over here on this side as well, I've got some LEDs that are out. So the customer brought it to me because he took the lens off of the front of it and he noticed some of these little coils that they glued down with silicone just aren't holding any longer. That one is definitely not even connected anymore. You can actually see the lead is off of it right there. So is that the entire problem? Just these coils have broken loose? If that's the case, I wonder if I can do a measurement and find out what the microhenry value is and find some replacements for this guy. So I've gone ahead and marked the defective LEDs with the little blue dot. There are always 3 that are out in a group, but unfortunately that one right there is absolutely gone. It's missing from the circuit board. So these 3 right here are out, and that's the one that had the broken coil that we could actually see the wire broken off of. These 3 are out, and that's the one that's missing the LED. These 3 are out right here, and the coil is once again missing. It's not even there. I went ahead and soldered a couple of tabs so that I can clip my leads onto it. Then I'm just going to put my voltmeter on it in the amp mode and fire this up and see what kind of current we're looking at across these coils so I can get a suitable replacement. Kind of hard to see, but we're looking at 470 milliamps right now. Almost half an amp. If I move this over a little closer. We're climbing up to 478. Maybe after it runs for a few minutes, it will climb up a little bit more. But if I can find a suitable replacement LED and some replacement coils, I think we'll get this light bar up and running once again. So we're up to almost 480 milliamps. So I'm going to venture to guess that as this thing warms up, it might possibly even go up to 500, maybe even up to 600 milliamps. So I need to consider that when choosing a replacement inductor. So now the other thing to consider when choosing a replacement part is physical size. So I need to go ahead and measure this. Find out what the pad placement is. So I've got 5.63 millimeters. So I'm going to go back on Mouser, browse their website, and see if I can find a replacement inductor, 68 microhenry with a 5.6 millimeter footprint. Okay, so I have found some Born's 68 microhenry inductors. Here's the technical specs down here. I went ahead and chose one that was good for 1 amp DC current, so a little over double what we need. We're seeing about 470 milliamps right now. So I think 1 amp is going to be absolutely fine. So the footprint on this one is 5.8 millimeters by 5.2 millimeters with a height of 4.5 millimeters. So it's going to fit perfectly into this situation. So I'm going to go ahead and quote my customer to replace some of those, plus shipping obviously, because if it's 44 cents a piece, I'd just order 2 or 3 of them right now and be done with it. And as far as the defective LED, I have some replacement white LEDs. So I'm just going to go ahead and throw one of those into it. It doesn't have the dome top on it. It's just a standard LED with a couple terminals on the bottom. I'll go ahead and throw one of those into it. It's probably going to work just fine. It's meant for high output lamps, LED lights, where they require a lot of current. I think it's rated at about 300 to 500 milliamps with adequate heat sinking, of course. So I'll just go ahead and throw one of those into it. It may have a little bit of dispersion difference, but for this application, I think it's going to work just fine. Alright, so check out the shoddy workmanship on this board. This capacitor right here, the one end of it, it's not even soldered. They got the left end soldered, but not the right end. So I've got this on my LED rework station, and I'm heating it up, and once it gets up to temperature, I'll add a little bit of flux to it, and hopefully it'll just set right back down in place where it should go. So the solder is molten. I'm just going to add some flux to it here. And I'll grab my tweezers and just kind of give it a nudge. There we go, back in place, all soldered up. Okay, so this coil is bad. It's electrically good, but the core is broken. So I've got it on my LED rework station heating up the board. And once it gets up to temperature, I'm just going to take this coil off. And I'll go ahead and put a new coil on, which I have ready right here. It's almost there. I can see the solder as I drag the tweezers across it. It is becoming molten. There it is. I'll just pick off that old coil. I'll give it just a drop of flux. We'll set the new coil on the board. It's going to take a moment for the new coil to heat. Alright, that looks good. Let's go ahead and take it off the heat now. Let it cool off for a moment. I didn't notice it in my original estimate, but this one right here is physically cracked. The core is broken on this one, so we'll go ahead and just pop that off. I did order enough to completely replace all the damaged ones. It was going to have 4 bad ones, but I ordered 10 of them just to be safe. There we go, and that one looks like it once again has adequate solder. So we'll go ahead and add a little bit of flux to it. And the new one goes into place in this orientation. I'm just going to heat up the core with the hot air rework station real quickly. I'm just going to physically press it down to make sure that it is seated to the board good, and then I'll lift the board off of the heat and let it cool off. Okay, so I've got these 2 boards done. That's a new coil, that's a new coil, and I believe that one is as well. So I've got 3 bad coils replaced on these boards. So let's go ahead and power it up. I've got 13.5 volts on my test leads right here, so I'm just going to go ahead and attach it to ground and to VCC, and it should light up. And as you can see, every LED is working perfectly. So with 2 boards, we're drawing 3.7 amps. And I've got 13.1 volts right now. So this whole light bar has 8 individual boards in it. So let's figure out how many amps it should draw. So the thing should draw just shy of 15 amps. This thing should be very bright once it's up and running. So hopefully I'll be able to show you everything once I get it all put back together. Okay, so if you're doing one of these light bars and you want to take the modules out of it, the easiest way I found is to loosen the screws so they're just barely hanging on. Then you can slide them into the rail. And then butt them up against the next board and tighten the screws down. So now I've tried not to disturb the heatsink compound that's already on this unit. But you could always add a bit more heatsink compound if you wanted to. Now all I have to do is attach the leads from one board to the next, and we should be ready to go. Alright, so I've just got it propped up here. It's all back together. Oh my gosh, look at all those LEDs. Everyone is working. These things are bright. All the way to the end. Alright, well anyhow, there it is. Up and running again. Just had some bad coils, and I did replace one LED. Now I didn't have the original LED, so I just replaced it with a normal TV type LED, but it seems to be working just fine. So once again, at this point, I want to give a sincere thank you to those who have supported my channel with a donation via PayPal or by having me repair your unit like this one. If you enjoyed this video, please consider subscribing to my channel and liking this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter, at NorCal715. You can email me, norcal715videos@gmail.com. Go ahead and leave me a question, a comment, a concern down below. I try to read all the comments and answer when I have time. Remember, with your help, we can keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Thanks for watching this video. Once again, I really appreciate it. Everybody have a great day. Bye-bye.